Good evening everyone and welcome to my YouTube channel. So here today we are going to be looking at the roots of a quadratic equation. So what are the roots of a quadratic equation? These are simply values of x at the intercept. So if we have, let's say, the x or y plane, the point at which the equation crosses the x-axis is what we call the roots of a quadratic equation. So now under this topic we are going to be looking at the products of the roots and the sum of the roots. So if you look at this, you have your x and you have your intercept at this point, you have another intercept at this point. So the first intercept we are going to be calling it alpha, the second intercept we are going to be calling it beta. So therefore these are the roots of a quadratic equation. So this is how we do it. Now as you can see, if these are roots of an equation, we know that y is equal to 0. Now for any quadratic equation, it is given in the form ax squared plus our bx, then we have plus our c, like that. So this is how we find the equation of a quadratic equation. So now what we are going to find is that, let's see what happens when we divide a throughout over a over a over a. So the equation becomes x squared plus our b over a, then we have x plus our c over a. So now let's also compare. Let me put this by the side. So if we look at now, we are saying that alpha and beta are the roots of an equation. So this means that at this point we have, so the alpha and beta are just simply a fancy way of saying the x coordinates at where the graph passes the x-axis. So this can be, if a, alpha and beta are the roots, it can be written as your x minus your alpha, then we have also our x minus our beta, like that, should be equal to 0. Now why we are doing this is that if you look at your x minus alpha is equal to 0 and your x minus beta is equal to 0, you are going to find that when you take the value this side, it will be x should be equal to alpha. When you take this beta the other side, it will be x should be equal to beta, like that. So in this way, or rather in this regard, you are going to find that this is true. If you have x minus a and x minus b, it means to say your alpha and beta are the roots of an equation. So these are just a fancy way of saying it is the x coordinate at the x-intercept. So now what we are going to do is that we are going to, let's expand this. So this means that the first number multiplies everything. So we are going to have our x minus our beta. Then we are going to have our second number, we have minus our alpha, multiplies everything there, so it will be like this, should be equal to 0. X by x, it gives us x squared, minus beta by x, it will be beta x. Then we have x by alpha, it will be minus alpha x. Negative times negative, it will be positive. Then we have our alpha beta, like that. So now what we are going to have is that when we have our x squared, we can factorize the negative. We are going to have our negative, x is common, so we have x. Then when we open our brackets, negative has gone, it means to say we are going to remain with our beta, positive beta. We have plus, negative divided by negative is positive, alpha, like that. Then we are going to have plus our alpha beta, like that. So this, as you can see, we can just now rearrange this by just putting our alpha, though the way it was, it is still okay. So we have our alpha plus beta, like that. Then we have plus alpha beta, like that. So now when you look at this approach, we are going now to compare. So as we can see, both of these are quadratic equations. So now when our alpha is adding with beta, it means to say this is the sum of the roots. So therefore, we can equate these. So the sum of the roots means you are getting this. So you are going to have your negative x, open brackets, you have alpha plus our beta should be equal to, we have the beta over, or b over a, then we have our x. So we can, if x is the same on both sides, we can just divide it like that. We are having negative, open brackets, alpha plus our beta should be equal to b over a. Then we can multiply by -1 on both sides so that we get rid of the negative. Negative by -1, that is here, we are going to have positive. So we are just going to remain with alpha plus our beta, which should be equal to negative times b. It will give us negative b over a. So as long as you are dealing with the sum of the roots, we are going to be using our negative b over a. Let's get another thing and compare. So the product, which is alpha by beta. So you know that according to how we use to find the product, it's multiply the value that is here, which is our a by whatever is here. But our product will just be made of alpha beta, because 1 times alpha beta is still alpha beta. So this product, you equate it with the last part, which is your product as well. If you multiply 1 by c over a, that's how we find our product when we are dealing with factorizing. So the product of the roots is given by, so we can say product of roots. So products of roots, we have our alpha beta should be equal to, according to this we have, it should be equal to c over a. So we are going to have our c over our a like that. So this is how we find the sum of the roots and the product of the roots. Let's say we have this equation, then we are required to find the sum of roots and also the product as well. So how do we go about this? So let's find the roots of this equation, which occurs when when our y is equal to 0, where we have 0 there. So let's factorize this. So we have x squared minus our 2x minus 3 should be equal to 0. So our product should be equal to our AC, which is equal to 1 times our c is equal to -3. So our product is equal to -3. Our sum is equal to b, which will be equal to a -2. So this is our a, this is our b, this is our c. So we are going to have something like a negative. Then our factors, two numbers, which when we multiply them, they give us a -3. When we add them, they give us a -2. So these numbers are -3 and +1. So if we multiply them, they will give us our products. If we add them, they will give us our sum like that. So we are going to get these, replace them there. We are going to have something like x squared, then we have minus our 3x, then we have plus our x, then we have minus our 3 should be equal to 0. So we are going to have our x is common, then we are going to have our x minus 3 and plus 1, then we have our x minus 3 should be equal to 0 like that. So what we are going to end up with is, in one bracket we are going to have our x minus 3, in another bracket we are going to have our x plus 1 like that. So what we are going to have is that it should be equal to 0. So either x minus 3 is equal to 0 or our x plus 1 is equal to 0. So we take the 3 this side, it will be our x is equal to 3, or our x should be equal to -1 like that. So these are our values, which are the roots of the equation. So now what we are going to do is that let's find the sum. So sum of roots is, we are going to add our 3. Now we have plus, but this one is negative, so we can say -1, which will be equal to 3 minus 1, which is equal to 2. Then the product of roots is found to be we have our 3 by negative 3 or negative 1. So we are going to just multiply 3 by negative 1, which is giving us a negative 3. So our product, our sum is equal to 2. Our product is equal to, we have our negative 3 like that. The equation was x squared minus our 2x minus 3 like that. So now, using the alternative that we have found, we have said that the sum of the roots, which are alpha plus beta, so you can just put our sum of the roots should be equal to negative b over a. So our negative b, so this is the coefficient here is our a, we have our b, then we have our c. So we have our negative, where there is b, we are going to open brackets negative 2, then we have over our a, which is equal to 1. Negative times negative, it will be positive, so we are going to have a 2 like that. So this is the sum of the roots. Now remember, we found a 2 just by adding normally. We found a positive 2. Let's see the product. So to find the product of roots, we are going to use alpha beta should be equal to our c over a. So in the quadratic equation, our c is equal to negative 3 over our a is equal to 1. So our product of the roots is giving us a negative 1. This one is giving us a positive 2 like that. So this is how we are going to be answering. Just to find the sum, we just add them and it gives us a value. To find the product, we are just going to use our c over a like that. So let's now derive identities that are going to help us. So let's say we want to find the identity that can be used for alpha squared plus our beta squared like that. So this identity, to derive it, since we have a plus b, what we are going to do is that we are going to just remove the powers and say a plus beta like that, then square it, expand this. So the expansion of this equation is the same as having alpha plus beta. Squared means let it come twice, alpha plus beta like that. So we are going to find that, let this first one multiply everything, so it will be our alpha times our alpha plus beta, which is this other equation. Then we have plus, let the second number multiplies everything, so we have beta times our alpha plus our beta like that. So this will give us a value alpha by alpha, it will give us alpha squared. Then we have plus alpha by beta, it will give us alpha beta. Beta by alpha, it will give us alpha beta. Then beta by beta, it's going to give us a beta squared. So we have alpha plus our beta squared like that. Then we can just put, so we have our alpha squared plus alpha beta plus alpha beta. This will give us a 2 alpha beta. Then we have plus our beta squared like that. So this will be our alpha plus our beta squared. Then what we are going to do is that we are going to just put them close. So we have alpha squared plus our beta squared. Then we have plus our 2a beta. Then this side we have our alpha plus our beta squared. So all we are going to do is that we are going to get this value and take it this other side. So what we are going to have is our alpha plus our beta squared. Then we have minus 2 alpha beta, when it comes this side, should be equal to alpha squared plus our beta squared. So this is the first identity, which is our alpha squared plus our beta squared should be equal to, we are going to have our alpha plus our beta. We are just rewriting everything, beginning with alpha squared plus beta squared. So we have squared minus our 2 alpha beta like that. So this is how we derive this identity. Very, very important. Let's derive another identity. So remember this identity. So we are going to have our identity number 1 like that. Then what we are going to have is that identity number 2, we are going to derive it from, let's say we have our a minus beta squared like that. Then this one should be equal to, so this expanded, it shall be our alpha minus beta times our alpha minus beta. That's the meaning when we have a square outside the bracket, minus beta. So expanding this first number multiplies everything. So we are going to have this second number with everything. We are going to have something like this. So alpha by alpha, it will give us alpha squared. This by this, it will give us minus alpha beta. This by this, it will give us minus alpha beta. Beta by beta, it will give us positive beta squared like that. So what we are going to have is that our alpha squared, then we can just bring this value here. We are going to have plus beta squared. Then we have negative alpha beta minus alpha beta. This will give us minus our 2 alpha beta like that, which should be equal to our alpha minus our beta squared like that. So this is our identity for alpha minus beta squared. It's alpha squared plus beta squared minus our 2ab, which is similar to what we got at first, but here it is plus, there it's minus. So now what we are going to do is that, this. Now under this, what we need is alpha plus beta showing and our alpha beta. These two are acceptable, but not minus. Minus is not acceptable because we don't know the identity for that one. So now already, so the identity for alpha beta, to find the value of alpha minus beta, you are going to use this identity. Now this means that just alpha minus beta should be equal to, first let's write everything there. To find that, we are going to square root both sides to find what your alpha minus beta is equal to. You square root both sides, which is going to give you the square root of our alpha squared plus our beta squared minus our 2 alpha beta like that. But now okay, let's take it from here before we square root that one. This one is incomplete. Let's finish it, then we can go to this. So as we can see from the first identity, we have our alpha squared plus beta squared. This will give you something like this. So what is common is we have this and this. So now that means to say, wherever you see your alpha squared plus beta squared, always replace this value. Always replace this value. So this value can be used to find the value of alpha squared plus our beta. So now it means to say, wherever you see alpha squared plus beta squared, you are going to add it. So you are going to say alpha minus our beta squared should be equal to, where there is alpha squared plus beta squared, you are going to put the value which is equal to the alpha plus beta squared minus 2 alpha beta. But wait, we also have another value at the end, which is our 2ab, which was independent, by the way. So we are going to still say minus our 2 alpha beta, because this is just for where there is alpha squared plus beta squared, we have this identity. So we are going to have our alpha minus our beta squared. This should give us a value that is equivalent to alpha plus beta. Then negative 2 alpha beta minus 2 alpha beta will give us minus 4 alpha beta like that. So this is the identity. So as long as you have alpha plus beta and alpha minus alpha beta, then it is well. So what we are going to have is that to find our alpha minus our beta, we are going to just square root both sides. So square root both sides to find your alpha minus beta, which shall be the square root of our alpha plus our beta. Then we have our squared minus our 4 alpha beta, like that. So this is the identity that can be used to find the alpha minus beta without the squared. So alpha minus beta, if there's a squared, this is the identity, like without the square root, like that. So let's just write. So this is what we have. Let's go to another identity. So let's say we also have our alpha squared minus our beta squared. So as you can see, this is a difference of two squares. Being a difference of two squares, it means to say it can be expressed as our alpha plus alpha. You take the negative, so we have alpha minus beta. Then the second bracket, we have our alpha plus our beta. So you take first the negative, then the positive. So as we know, our alpha minus beta is equivalent to the square root. So we have our square root of our alpha plus our beta squared. Then we have minus 4 alpha beta, like that. Then multiplied by alpha plus our beta. So this is the identity. This is the identity of alpha squared minus our beta squared, like that. Just lift what this is equal to, the square root of that. So this is how we find the value for that one. The other identity that we are going to derive is alpha cubed plus beta cubed. So this one is coming from having our alpha plus our beta, like that, cubed. So this should be equal to, let's expand this. So this means to say we have 3 of them if we have the power 3. So we have something like this, something like this, and something like this. So this is what we have. So first, let's just multiply this and this. Let's first multiply the first 2 of them. So we have the first one multiplies all of these numbers. So we have alpha by alpha. It will give us our alpha squared, like that. Then this alpha multiplies the second number, which is our b there. We are going to have our alpha beta, like that. Then we are going to have something like this. When we multiply our beta now, we are multiplying it with this one. We are going to have our plus alpha beta, like that. Then our beta, when we multiply it with the second value, it will be plus our beta squared, like that. So then we have, this should be multiplied with our alpha plus our beta, like that. Then what we are going to get is that we have our alpha squared plus our beta squared. Then alpha beta plus alpha beta will give us 2 alpha beta, like that. Then we have times our alpha plus our beta, like that. So this gives us this gives us this. So expanding this further, so here we have our alpha. Okay, we are going to write it there. So this value multiplies everything there. So we are going to have something like, we have our alpha multiplies everything, which is our alpha squared plus our beta squared plus our 2 alpha beta, like that. Then our beta multiplies everything, which can be written as plus our beta times our alpha squared plus our beta squared plus our 2ab, like that. So we are going to have alpha by alpha, it will give us alpha cubed, plus alpha by beta, it will give us alpha beta squared. Alpha by this, it will give us plus our 2 alpha squared beta. This by this, it will give us plus our alpha squared beta. This times this, it will give us plus our beta to the power 3. beta by alpha beta, it will give us plus our 2 alpha beta squared, like that. So this is what we have as our alpha plus our beta to the power 3, but we are trying to find what our alpha cubed plus our beta cubed is. Keep that in mind. So now what we are going to get is that we are going to get that our alpha plus our beta to the power 3 should be equal to, let's add whatever is similar. Let's begin by just putting these close. So we have our alpha cubed plus our beta cubed, like that. Then we are going to have, let's add whatever is similar. So we are going to find that the terms that are similar are this one and this one. So our 1 times or plus 2, it will give us plus 3 alpha beta squared. Then this one, we are going to add it with this one because this is the a squared beta. So we are going to have plus our alpha squared beta, like that. Sorry, let's add them. So we have this term 2 alpha squared beta plus alpha squared beta to give us a 3 alpha squared beta, like that. So these are the terms that we have found after adding each and everything. So what we are going to do is that we are going to have our alpha cubed plus our beta cubed. Then we can factorize. 3 is common, so we have plus our 3 alpha. Then we are going to have our beta is also common, alpha beta is common. Then what we are going to remain with is, here since it's b squared, it will remain with beta. Then we are going to have plus. Here, since the a is the one that is squared, it is the one that is going to remain, like that. Then we have our alpha plus our beta to the power of 3, like that. So already, just take this value the other side. It will be our alpha plus our beta to the power of 3 minus, we have our 3 alpha beta, open brackets, beta plus alpha, which can just be written as our alpha plus our beta. So alpha plus our beta, like that, should be equal to, we are remaining with our alpha cubed. Then we have plus our beta cubed, like that. Summary of the identities that we have looked at. So we have looked at this one. We have looked at this one. So it is good if you can memorize all of them. It is possible that you can memorize the formulas. If you want, you can just be deriving each and every time you're given a question. So as you practice more, you will find that these things just begin to flow and they just begin to be part of you. So these are the identities that we are going to use for now. Then later in the video, we are also going to introduce other identities. So let's look at a question. So let's say we have, if the roots of an equation 2x minus 5x, so we have a 2x minus 5x, 2x squared minus 5x plus 1 should be equal to 0. Then we are told that our alpha and beta, find the value of our 1 over alpha plus our 1 over beta. So here, what we are going to do is that we are going to say, first let's find the sum before we even begin our calculations for many of these. Sum should be equal to negative b over a. So this is our a, this is our b, this is our c. So our negative b, so we have negative, where there is b, we are going to put a negative 5 over our a, which is equal to a positive 2. So we are going to find that our sum is equal to positive, negative times negative is positive, 5 over 2. So this is our sum, which should be equal to negative b over a. So this is our sum. So remember this value. Then our product was equal to c over a. So just get the coefficient of c, which is equal to 1 in this case, 1 over our a, which is equal to 2. So we are going to put 2 there. So the product, which is where you have alpha beta, should be equal to 1 over 2. Where you have the sum, which is your alpha plus beta, you are going to put the value that is equivalent to a 5 over 2. So therefore, if you are asked to find, let's say, your alpha, let's say you are asked to find, now we have our 1 over alpha plus 1 over beta. We are asked to find the value. So we are going to say, let's find the common denominator. So the common denominator is alpha. So we are going to say alpha, we combine it with beta. So as long as you have gotten both equations, it means to say just multiply this and this. It will be beta. Then we are going to have plus alpha by 1. It will be alpha like that, which can be written as our alpha plus our beta over our alpha beta. Now we know that our alpha plus beta, which is our sum, alpha plus beta, this one is equal to 5 over 2. So wherever we see sum, which is our alpha plus beta, we are going to say 5 over 2. Then we are going to say divide by alpha by beta. This will give us a value that is equal to 1 over 2. So we are going to say divide by a 1 over 2. Remember these values, we are going to be using them throughout this same example. So we are going to have a 5 over 2. Then we multiply. The 2 will go up like that. So this one and this one goes. So the value of the equation, which was our 1 over alpha plus 1 over our beta, should be equal to just a positive 5. So this is our answer for this one we have evaluated. So we have, let's say for our b, we are required to find the value of our alpha squared plus our beta squared. So now, the identity for this one, we know that alpha squared plus our beta squared, we found something like alpha plus beta, then we have squared, then we are going to have minus 2 alpha beta like that. So this is the identity. This is the identity for this one. So we are going to find that as long as we are adding alpha plus beta, we said that this is equivalent to 5 over our 2, which we have already found. So we have our alpha plus beta, we have a 5 over 2, then alpha by beta, it is equal to a 1 over 2. So we are going to have 1 over 2 squared minus our 2, where there is alpha, we are going to put our 1 over 2 like that. So we are going to end up this and this will cancel. So we are going to have 5 squared, it will give us a 25. The 2 is distributive, meaning to say it affects the numerator and the denominator. So we have 2 squared, we are going to have over 4 minus 1 like that. So alpha squared plus our beta squared, this value will be equal to, we have a 4 like that. Then 4 divided by 4 is 1 times 25 is 25 minus 4 divided by 1 is 4 times 1. It will give us a negative 4. So 25 minus 4 will give us a 21 over 4. So this is the value of a squared plus b squared. So the question is just find the value of any of the given things that we are going to be looking at. So that is how you find that one. Let's look at this other one. If you have your alpha minus your, let's say, your beta. So if you recall, the value of this is equal to the square root of our alpha plus our beta, then squared minus, we are going to have our 4 alpha beta like that. So this is the identity that we are going to use to find the value. So we are going to have the square root of our alpha plus beta is equivalent to, we have alpha plus beta, we know that it's 5 over 2 squared, then we have minus 4, where there is a, we are going to have something like alpha beta is equal to 1 over 2 like that. So what we are going to get is that we have the square root of our 5 squared will give us 25 over 2 squared will give us 4 minus. Then we reduce here, we are going to get a 2 there, so we have minus 2 like that. Then we are going to find our square root of, we have our 4 like that. 4 divided by 4 is 1 times 25 is 25. Then we have minus, we have 4 divided by 1 is 4 times that, it will give us 8. So when we subtract our 25 minus 8, it will give us a 17. So we are going to have the square root of 17 over 4 like that. So this is the value of a minus b. So let's finish it. So it's either the square root is distributive, meaning to say it can be written as the square root of 17 over the square root of 4, which will give us always a plus or minus. So we have alpha minus beta. So the roots are either the value of alpha minus beta is equal to either positive square root of 17, the square root of 4 is 2, or you can take the negative, in which you are going to say alpha minus beta is equal to negative the square root of 17 over a 2. So we have taken plus or minus like that. So that is how we find the value for that one. Then let's look at our next question. So let's say we have the value of this one, alpha squared minus our beta squared. So this shall be equal to, we know the identity should be equal to the square root of, we have our alpha plus beta, then we have minus 4 alpha beta, then we are going to get times our alpha plus our beta like that. Then what we are going to have is that our alpha squared minus our beta squared should be equal to, we are going to find that this will be our square root of alpha plus beta. We know that this is equal to 5 over 2. Now let me clarify something. You only know that it's 5 over 2 because the equation is the same. So we use the same equation. Provided with a different equation, it means to say we have to find the sum and the product. But in this case, we have already, it's just one equation we are using. So the sum, which is our a plus b, is the same throughout. So we have squared minus, we have our 4, our product, which is our ab, alpha by beta. We are going to put a 1 over 2. Then times our alpha plus beta, which is a 5 over 2. So if you recall, this exact value 5 over 2 squared minus 4 times half, instead of us wasting time, we have already found it. It is exactly the same here, which is our 5 over 4, 2, we got a 17 over 2. So we are going to get a plus or minus the square root of 17 over 2. Then we multiply by, we have the value which is our 5 over 2. So we can get this 5. If it multiplies, it can come there. Then we are going to have a plus or minus 5. Then we have the square root of 17 over this 2 times this 2. It will give us a 4. So either, so our alpha squared minus our beta squared is either is equal to, alpha squared minus our beta squared is equal to positive 5 square root of 17 over 4, or we can have our negative 5 square root of 17 over our 4 like that. So then let's move on. So let's have our next one, which is saying that, let's say we have 1 over our alpha squared plus 1 over our beta squared. So this should be equal to, the common denominator will be both of these. So we are going to have our alpha squared by our beta squared like that. Then this one multiplies that, as long as you have gotten them. Then we are going to have beta squared plus our this by this, it will give us alpha squared. So just rearranging them, we are going to have alpha squared plus our beta squared over, this can be written as our alpha beta the power 2 is common, so we are going to have something like this. Now to find the value, it means to say if we don't know the value of alpha squared plus beta squared, we were going to find what the value is equal to. But since we know what alpha squared plus beta squared is equal to, we can just be able to replace. So the value that it gave us was a 21 over 4. So we are going to get, we are going to get a 21 over 4, then say divide by, we have our alpha beta is equal to 1 over 2, then we have squared like that. So this will give us a value that is equivalent to 21 over 4, then we have divide by 2 squared there, it will give us a 1. It will give us a 1 over 2 squared, which is equal to 4 like that. So what we are going to have is a 21 over 4. Then we have times our 4 over 1 like that. So this and this goes. So we are going to have a 21. So this is the value of our 1 over alpha squared plus 1 over our beta squared like that. So this is the value. So the value is equal to 21. So this is how you solve values. Let's also look at this one. A to the power 3, alpha to the power 3, then we have beta, then we have plus alpha beta cubed like that. So what we are going to do is that let's factorize. Each and every time you have something common, factorize. So our alpha is common, our beta is common, then what we are remaining with is alpha squared plus our beta squared like that. So that means to say if you did not find what alpha squared plus your beta squared is equal to, there will be need for you to be able to find the value using this identity. Now that we already know what the value of this is equal to, we can just replace. So we have our alpha beta is equivalent to, we have a 1 over 2 times alpha squared plus beta squared. This was the one that gave us a 21 over 4 like that. Then we are going to multiply 1 by 21. This will give us a 21 over 2 by 4. It will give us 8 like that. So this is the value. So they want the value. So this is the value of a to the power 3 beta. Then we have plus our alpha beta cubed. So this is how we find the value of this one. So just get this. If you don't have this, it means to say you have to manually find it by using the identity alpha plus beta squared minus 4 alpha beta. So you should be practicing not 4 but 2 alpha beta. You should be practicing while you are watching the video, so that the more you practice, the more it will become a part of you. Let's move on. If you have, let's say, your alpha to the power 3 plus your beta to the power of 3, so what you're going to do for this one is that you know that this identity, according to what we got, should be equal to alpha plus beta, then we have to the power 3, then we are going to have minus 3 alpha beta, then we have our sum, which is our a plus, or rather alpha plus beta like that. So if you don't know how to do this one, if you don't know how to get to this one, you can just memorize the formula. If you know how to memorize, how to derive, but you don't know how to memorize, you can just derive when you are given a question. So we are going to have alpha plus beta. Alpha plus beta is giving us a value that is equivalent to a 5 over 2, if I'm not mistaken. Then we have to the power 3, then we have minus, we are going to have something like this. We have our 3, where there is alpha by beta. We know that alpha by beta is 1 over 2. Then we have the sum, which is equal to a 5 over a 2 like that. Then we are going to 5 to the power 3, that gives us 125 over 2 to the power 3, that's 8. 3 by 1 by 5, it will give us a negative 15. 2 times 2, it will give us a 4. Find the common denominator, which is 8. 8 divided by 8 is 1 times 125, it will give us 125. 8 divided by 4, that will give us 2 times 15, it will be negative 30, like that. Then our 125 minus 30, it will give us a 95 over 8. So this is the value of a cubed plus our b cubed, like that. Okay, so let's move on to our next one. Let's say we have our alpha to the power 4 minus our beta to the power 4. To find the value of this one, for the same equation that we were given, we are going to just say that the value shall be equal to, this can be a difference of 2 squares, in the sense that this can be equal to our a to the power of 2, then we have squared, minus our b to the power of 2, then we square it. So this is the same as taking first, we have the a squared, taking negative there, we are going to have minus b squared, like that. Then for the second part, there are 2 of these numbers, so we are going to take our alpha squared, then we are going to have plus. So the second one, when you take it, it's plus. That's how difference of 2 squares work, like that. So this is the identity for a to the power 4 minus our b to the power of 4, like that. So to find the value, what you can do is evaluate what the value of a squared minus b squared is equal to, which we found to, we said the square root of our alpha plus beta, then we have squared minus our 4 alpha beta, then we have times our alpha plus our beta, like that. So this is the identity that works for this one. So if we were not given the value, if we were not given this as a previous question, we were going to first find what value is this, then multiply it by the value of that. But we have already found all of this, so all we are going to do is substitute. But in the rare case you are not, this is the first question, it means to say first find the value of this, whatever value you will find, then be able to replace it there. Then finally also find a squared, alpha squared plus our beta squared. But in this case, since we have already found everything, we are just going to replace. So we have our alpha squared, alpha to the power 4 minus our beta to the power 4 should be equal to, so we are just using the same equation, remember that. So we have our alpha squared minus beta squared. This gives us a value that is equivalent to a negative plus or minus 5 over 4. So 5 over 4 times the square root of 17. So this one, we are going to replace it there. So we are going to have a plus or minus the 5 over 4. Then we had the square root of 17, like that, plus or minus. Then we are going to multiply this by what our alpha squared plus beta squared is giving us. So alpha squared plus beta squared gave us a value of, so first let's verify. This gave us plus or minus 5 square root of 17 over 4. So we are going to take the value. Alpha squared plus beta squared gave us a 21 over 4. So we are going to get this 21 over 4 and put it there. So we are going to have times our 21 over our 4, like that. Then we multiply. So what we are going to have is 5 by 21. This will give us a plus or minus, don't forget, plus or minus 105, like that. 21 by 5, it will give us 105. Then we have the square root of our 17. 4 by 4 will give us a positive 16, like that. So this is how we find the value of our a to the power 4 minus our b to the power 4. For our last one, let's say we have our a to the power of 4, then we have plus our beta to the power of 4. So this identity, we are not going to derive it, but I'll just give you. So this is how it goes. So to help you remember, this identity, I'm going to give you this form: sum to the power of 4. Then we are going to have a minus 4 sum to the power of 2. Then we have the product. Then we have plus 2 product squared, like that. So this form will just help you, so you can just write this form so that it helps you be able to remember. So this means that the identity alpha to the power 4, then we have plus our beta to the power 4 should be equal to our sum, which is equal to alpha plus our beta, which is the sum you add to the power 4 minus 4. Then we have our sum, we are going to say alpha plus our beta. Then we have our squared. Let me move it a bit. So our product is equal to alpha by beta. Then we have plus our 2. Then we have the product squared, which is our alpha beta to the power of 2, like that. So we are going to get power to the power of 2. So expressing it in this form really helps you simplify things. S to the power 4 minus 4 sum to the power 2p. So if you can just remember these letters, you can be able to easily be able to write that. So to find the value of this, so we have our alpha to the power 4 plus our beta to the power 4 should be equal to alpha plus beta should be equal to, we know that we have power 4 there, alpha plus beta to the power 4. Alpha plus beta was our 5 over 2 to the power 4. Then we have minus our 4. Alpha plus beta is 5 over 2 to the power of the 2. Then alpha beta is our 1 over our 2. Then we have plus our 2 alpha by beta, which is giving us a value that is equivalent to 1 over 2. Then we have a squared there. So we are going to have a value that is equivalent to 5 to the power 4 gives a 625. So 5 by 5 is 125, like that. 5 by 5 is 25, by another 5 gives us 125, by another 5 is 625. Then our 2 to the power of 4, this should give us a 16. So this is equal to a 16. Then we have minus 4. Then 5 squared, this will give us a 25, over 2 squared will give us a 4, like that. Then we have by our half, like that. Then we are going to have this, we can't cancel like that since there is a number. So we have 2 times 1 squared is 1, 2 squared is 4, like that. So this is what we have. So we are going to simplify things. So we have a 625 over a 16. Then we have minus our 4 by 5. It will give us a 100. So we have minus 100, like that. When we multiply 1, it won't change anything. Then we have over 4 by 2. It will give us 8. Then 2 by 1 over 4. This will reduce to a 2 there. A 2 there. So we are going to have plus a 1 over a 2, like. Let's find our lowest common denominator, which is our 16, like that. 16 divided by 16, that's 1 by 625. So we are going to have 625. 16 divided by 8 is 2 times 100. It will be minus 200. So 2 by 100 is 200. 16 divided by 2, that's 8 times 1, that's 8, like that. Then all we are going to do is add. So we have a 625 minus a 200. So this will give us a value that is equivalent to 524. 425. Then we subtract this. We add 8. So 8 is positive. So we add 8. This will give us a value that is equivalent to 5 by that. It will give us 13. Then we have a 2. We add 1. It's 3. So we have 433. So the value is a 433 over 16. So this is our alpha to the power 4 plus our beta to the power of 4, like that. So that is how we deal with those problems. Let's just look at our last parts to finish the topic. So the other type of a question that they might ask you under this topic is, if alpha and beta are the roots of the equation x squared minus 4x plus 2 should be equal to 0, then we are told find the quadratic equation whose roots are alpha plus 2 and beta plus 2. So this is a separate question. Our A is a separate question. Then we have our B. So this is our A, this is our B, like that. So the first thing that we are going to do is that just find the sum normally. So if you have your x squared minus your 4x plus our 2 should be equal to. So first find the sum of the roots. In other words, wherever you're going to see your alpha plus beta, you are going to say that this should be equal to a negative b over a, which should be equal to negative, our b is negative 4 over our a is 1, which will be negative times negative, it will give you positive 4, like that. Then what we are going to have is that also find the product of roots. So product of roots, so the product of roots is equal to alpha beta should be equal to our c over a. So see, the value of c is 2 over our a is 1, so we are going to have our 2, like that. So now wherever you see alpha beta, you replace with 2. Wherever you see alpha plus beta, you replace with a 4, like that. So now what we are going to have is that let's now get these roots. So these roots are alpha plus 2 and our beta plus 2. So we can say these new roots, we can say sum of roots is equal to, we add them, so a plus 2 plus beta plus 2. So 2 plus 2 is 4. So we are going to have alpha plus beta plus our 4. So now to find the sum, it means to say where we see a alpha plus beta, it is equal to a 4 that we found, then we have plus our 4. So we said here we found it to be alpha plus beta is giving us 4. So we write a 4 there, 4 plus 4, which is going to give us 8. So this is the sum of the roots. Let me move it. We are also going to take our product of roots. So our product of roots is such that we are going to have these same ones, we are going to multiply them. So alpha plus 2 times our beta plus 2. So when we multiply this, so this is our product of the roots. This is going to give us, so the first one multiplies everything like that. Then the second one also multiplies everything. So we have something like this. So this by this, it will give us alpha beta. Alpha by 2, it will give us 2 alpha. This by this, it will give us plus 2 beta. This by this, it will give us plus our 4, like that. So this can be simplified as our alpha beta. Then we are going to have plus 2. We can factorize, the 2 is common. We are remaining with alpha plus beta. Then we have plus our 4, like that. So this is alpha beta plus 2 alpha plus beta plus 4. So this is how we are going to find our product. So remember, we are on our product. So alpha beta, wherever we see alpha beta, we said that it is equal to 2. So we are going to say this is 2 plus 2. Our alpha plus beta is equal to a 4. Then we have plus our 4 there. So we are going to get our 2 by 4, it will give us 8 plus our 4. So 2 plus 8, it is going to give us 10 plus 4, which is going to give us a 14, like that. So this is the product of roots. This is the sum of roots. So now the question was, find the quadratic equation whose roots are these. So to find the equation, this is the formula we use. So to find the equation, this is simply, which we talked about at the beginning of the video. It is x squared minus, you are going to say minus x times the sum of roots. Then we are going to say plus our product of roots. So we have our x squared minus x, then our sum of roots was found to be 8. So we are going to put our 8 there, then we are going to have plus our product of roots is equal to a 14. So we are going to say x squared minus 8 by this, it will give us 8x, then we have plus our 14 like that. So this is the new equation that is required using the roots, having the roots of the equation which are alpha plus 2 and beta plus 2. Let's look at this other one. So you use the original equation. So we had x squared minus 4x plus 2 minus 4x plus our 2 should be equal to 0. So same approach. Let's first find our alpha plus beta. We have found this value to be alpha plus beta is equal to negative p over a, which is equal to negative. B is negative 4 over a, which is 1. Our sum is this. Then alpha beta should be equal to, we are going to have our c over a, which is a 2 over 1. We found it to be 2 like that. So we have a 4 and a 2 like that. Now, to find the equation that has got roots that are passing at 1 over alpha and 1 over beta, so you are going to say sum of roots. The sum of roots is equal to, we have 1 over alpha plus 1 over beta. So sum you add. So we are going to have same approach, alpha beta. Then we are going to have this multiplies that. So we are going to have beta plus alpha like that. Then this will give us alpha plus our beta over our alpha beta like that. So this is what we have for this problem. So now when you have done that, you know that your alpha plus beta, wherever there is this, we have established that the value is equal to 4. So we are going to put our 4 over, we have our alpha beta, which is equivalent to, alpha beta is equivalent to, what value was that? Yeah, so alpha beta is equal to 2. So we are going to put over 2, which is going to give us 2. 4 divided by 2 is a 2. Then the other thing is, so we have found the sum of roots. So let's find product of roots. So the product of roots is 1 over alpha. We multiply it by 1 over beta. So you just get those roots that we are now looking at. So we are going to have 1 by 1, it's 1 over alpha by beta, it's alpha beta like that. Excuse. So we are going to have 1 over alpha by beta is equal to a 2. So this is what we have. So to find the, we have found that the sum should be equal to, we have found it to be 2. The product is found to be equal to 1 over 2. So you can say that the new equation should be x squared minus x by sum of roots. Then we have plus the product. So we have x squared minus x, sum of roots is equivalent to a positive 2 like that. Then we have plus the product of the roots is giving us a 1 over 2 should be equal to 0. So what we can do is that to get rid of this 2 down there, we can just multiply by a 2 throughout. So 2 times x, it will be our 2x squared. Then here we have minus our 2x first. Okay, let's not do this first. Let's simplify. So we have plus 1 over 2 should be equal to 0. Let's now multiply by 2. So 2 by this, it will give us a 2x squared. 2 by this, it will give us minus 4x. 2 by this, it will cancel, because 1 over 2 times 2 will end up cancelling like that. So this will be equal to plus a 1 should be equal to 0. So this is how we find the equation with those roots. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.